My name is Chase Douglas. I'm the CTO and co-founder at Stackery, and I've got here my colleague, Anna. And today we wanted to talk about serverless, how it can be used as a mechanism for building applications in a pragmatic way, while still giving you the benefits of all of the ancillary techniques that you're familiar with for building production professional applications. So really quick, again, Chase Douglas, I'm the CTO and co-founder at Stackery. My focus through my entire career has been on building developer tools. I was the architect of New Relic browser, and now everything that I focus on is how to help people build modern applications in the best way possible using serverless architectural patterns.
Oh, hello. My name is Anna Spysz. I am a software engineer at Stackery. And unlike Chase, I actually don't have a long background in engineering. I'm pretty new to this field. I come from a background of writing and journalism. So I have been a huge fan of serverless ever since I discovered it, as well as infrastructure as code, because I feel like it makes infrastructure a lot more accessible, especially to beginners. But I'm getting ahead of myself a little bit. Let's do some definitions of what we will be talking about today.
Yeah. So through this talk, we're going to be focusing on lots of concepts, but there's a couple of definitions that would be helpful to get out of the way. You may hear us refer to CI, CD, and IaC. CI is continuous integration, CD is continuous delivery or deployment, and IaC is infrastructure as code. So let's start with that last one. What do we mean when we talk about infrastructure? Infrastructure is all about at a bare minimum, the physical resources needed for your application to run. So we think about servers in a data center. We might also think about networking equipment for the web applications to talk to the clients. Infrastructure now can also mean individual components of an application at a logical level. So it can mean compute resources like Lambda functions. It can mean API abstractions, API gateway, or AppSync for GraphQL applications. So that's the core of what infrastructure is. And as you build your web application, you have to piece these together and overlay it with business logic code. Piecing them together is something that you can do manually, say by pointing and clicking in a dashboard on AWS. But it can leave you with a sense of a jumble of components that are just kind of pieced together, hooked together. Similar to how a synthesizer might be patched together with patch cables. And you could make this work for one system, but then when you want to collaborate with other people on your team, if you go and take something like the synthesizer, and you said, go and replicate this, there would be a lot of errors, most likely. Infrastructure as code is a mechanism where you can codify how your infrastructure is put together so that it can be more repeatably deployed by different people and in different environments. In this sense, instead of having to reproduce the patching of a synthesizer wire by wire, it's almost akin to MIDI, where you can code all the interactions going on between different parts of your sound system. Now, let's focus on continuous integration, the first half of CICD. Continuous integration is all about how the changes that you write and you develop for your code can be tested and ensure that they incorporate correctly with the broader source code base that these changes are going into. For example, one thing you might test is linting. Not exactly this form of linting, more like this form of linting, where you're testing if the syntax of the changes that you've made conform to guidelines that you standardize for your team so that everyone can collaborate more effectively. It can also mean testing for functional capabilities. Once we've merged those changes into our main source code using a continuous integration approach, we can now focus on continuous delivery. This is all about how to safely get your code out into production. And ideally, you do that by breaking it up into small chunks and releasing to production frequently. You want your delivery pipeline to be like a German train system. It is frequent and it is always on time. That gives you the ability to de-risk your deployments and more easily deal with issues that might occur along the way. Lastly, we're going to take these concepts and think about them in terms of how they apply or even are strengthened by applying this serverless modern application architectural approach. Serverless is honestly a best friend of infrastructure as code and the other techniques that you can use to build applications. One of the reasons is that it ties together a microservice-based approach where you're creating your application out of many different types of managed services, like an API gateway, a functions as a service platform, a queuing service, a pub sub service. You're having to construct an application by combining infrastructure as code and the business logic together into one piece. So we're going to dive further into what this means in practice going forward.
And to answer why we would want to implement infrastructure as code in the first place, I feel like we need to look at the challenges inherent in managing infrastructure as it used to be before infrastructure as code. So before infrastructure as code, there was a great divide between dev or developers and ops or operations. So infrastructure was requested by the developers as they needed it, but they needed the operations team to provision that infrastructure. And this was also the case when it came to delivering the software. Developers needed the operations team to deploy every app update. This could result in gatekeeping because the knowledge between the two was so specialized and this workflow was handed off. There was not that much knowledge sharing between the teams. And some of this gatekeeping could also lead to a lack of standardization. So for example, best practices may not be documented, so it's really hard to standardize those. Or they could be reliant on one engineer, or every engineer had their own standards that came from their own work history. And this could lead to a mess of different standards. All of this made onboarding new team members, for example, a lot more difficult. This was also a very manual process. So sometimes manual to the point where if it was a data center, you would actually have to go in, put in new server racks and so on. But even in the age of VMs, you would still manually provision infrastructure in the console and so on. This was a little bit prone to bottlenecks because of that. And it was also prone to conflict. For example, if two developer teams needed specialized hardware, but there was only budget enough for one, well, what do you do? Or if the correct infrastructure wasn't provisioned in time for a major feature rollout, there could be problems with that. So all of this together meant that applications before infrastructure as code were slower to update. Rollouts weren't regular because it's really hard to move fast when you're waiting for other teams and relying on them. This meant this meant that bug fixes were also held up. And once those updates did go out, if anything went wrong, rollbacks were also slow because, like updating, they were a very manual process. So to address all of these challenges of infrastructure, infrastructure as code came along. And while infrastructure as code has been a best practice for anyone running virtual machines or containers for many years now, serverless kind of changed the game because now it's an absolute requirement.
Yeah, so again, now we're moving into this modern world where we're dealing with serverless solutions. It's the marrying of infrastructure as code to create a patch of many different managed services together that then you deploy your code on top of to deliver an end result for your customers. This marrying of the two, infrastructure as code, serverless, business logic all together, provides an opportunity for a lot of cultural benefits as well. So where in the past, because the developer teams and the operations teams were doing very different kinds of work, and they were doing it in different areas, different code bases, or even different physical locations, there was a divide that formed. But now with serverless, everything is managed as one project. So that divide is collapsing. It gives the ability for there to be more knowledge sharing. So all of the skills that the operations teams have built up about how to manage infrastructure, how to manage deployments, rolling them out, automation, they're now able to share more directly into teams of application developers that are using serverless to provision applications that include the infrastructure. Vice versa happens as well. You've got your application developers that are able to share insights on how their code can work better with different infrastructure approaches. With this knowledge sharing, we now have a greater capability to standardize processes across different types of applications and across teams. And that gives us the ability to move faster. So as we're developing our software, the next step in doing it well is being able to automate it. Automation is what makes teams start to become much more productive. But that automation requires tools and techniques. And infrastructure as code starts to allow us to automate the provisioning of infrastructure, and serverless gives us the ability to automate the deployment of the code on top of that infrastructure. Lastly, now that we're all in the same code base for both our infrastructure and our source code, we can now manage it using familiar tools. We can use GitOps workflows to create pull requests, to review them, to merge them, even if multiple people are working on the same project at the same time. This all gives us an ability to move much more faster, be a more productive team that ships updates more frequently and more quickly, and doing so with the ability to quickly and easily roll back if anything problematic happens. With infrastructure as code and a serverless approach, where you're combining both the infrastructure deployment and the business logic deployment, if anything goes wrong, you've got one place to roll back both at the same time.
So now that we know the what and the why of infrastructure as code in a serverless architecture, I want to spend some time looking at the how. How does a serverless team implement what we've talked about? And well, as a former professional storyteller, I think this is all easier to understand in the context of a story. So for the rest of the presentation, I'm going to introduce you to a startup that is implementing infrastructure as code and follow them in their journey into serverless application development and delivery. So meet the noisy herd team. This is the noisy herd team, and definitely not the result of a Google image search for startup stock photo. The noisy herd team runs a virtual event platform, and boy, are they busy these days. The noisy herd team is also very pragmatic. They want to focus on making the best event platform they can, and not on the intricacies of infrastructure or container orchestration. So they went with a serverless approach defined by infrastructure as code. So why did they go with serverless for their project? Well, first of all, events are bursty workloads by definition. So serverless allows the app to scale up quickly when there's a demand. So for example, if there's a Python web conference, they might have greater demand on their platform for a few days. So they need to scale up their application and have more instances of it. And then when that event is finished, they can scale down afterwards to almost nothing, which means, first of all, they're saving a lot of money by not having servers running all the time with their application. And they're also improving performance during those busy times for their app. Serverless allowed the team to define an architecture of managed services defined by infrastructure as code and version control. So everything they need is defined in a template, and provisioning additional infrastructure is as easy as adding to that template. It also gave them the ability to choose the managed services they need to build a video streaming platform, such as AWS Media Live. This allows them to focus on their business logic and not on reinventing existing services that are already well documented and supported by their cloud provider.
But as they're adopting serverless as a mechanism, they're having to realize this through infrastructure as code. And it has challenges. We've been talking about all the benefits that it can provide, but it's not the simplest tool in the shed to use and to learn. But with any great tool and mechanism, once you do have the ability to learn that, you can reap a huge amount of benefits. Infrastructure as code tends to come in the form of templates, like what we see here. It's a declarative syntax. Everything in the file is managed as one asset that is evaluated all at once. And this is great in one sense. It maps to a sense of you need all the infrastructure at one place in time for the application to succeed. But as you can kind of get a sense, if you look at the mini map on the right side of this template may be thousands of lines of code long. So as you're building your application, you have to start to come up with strategies for how you manage development against this very dense, this very challenging and new way of coding parts of your application. One way that we've found effective inside of Stackery is to provide people with a visual overview of it, a canvas that enables them to see the relationship between resources defined inside of their infrastructure as code templates. That makes it more easily understood from one person to another. So if I am an engineer on a team and I'm working with a brand new person who just joined, I can now show them this visual overview, and they can now more quickly understand at a human level what resources relate to other resources. So we can dive in more quickly to address individual bugs that we need to fix or add functionality to bits and pieces of our application. Once we have this template for infrastructure as code, now we've got a great starting point for being able to stamp out isolated environments for our infrastructure. So as I'm doing development, I certainly don't want to be developing against production as a general case. What I want to be developing against is a separate environment so that if I accidentally drop a database table, I've only dropped it from my development environment and not in production. To get to the point where we have these multiple environments, I need to then start thinking about parameterization and further into secrets. We certainly don't want to be committing our database password to GitHub. So when we create these separated environments, there's going to need to be some changes between them. We can store these inside of namespace locations of services that our cloud provider makes available to us. So for example, my database password, I need to store that somewhere, and I need it to be in a separate location for my development environment, my staging environment, and my production environment. AWS provides a service called Secrets Manager as one example, though all the cloud providers have mechanisms for this. Inside of Secrets Manager, I'm going to store these secrets under a namespace. So for my development environment, I'm going to store my database password under /dev/database password. I'm going to do the same thing for staging and production. This gives me the ability to have separate locations for these secrets and to provide permissions so that my development environment can only access secrets underneath /dev. Production can only access secrets under /production. We've talked about this in terms of secrets, but I can use the same mechanisms to parameterize my application. So in development and in staging, I don't care quite as much about the domain that's used for my API. It's fine if it has a bunch of random numbers and characters in it. But in production, I need to have a parameter that says use the noisyherd.com domain name. Parameterization that can be performed by storing parameters inside of a service like AWS Systems Manager Parameter Store enables us to use those parameters for our Noisy Herd application independently in each environment that we're deploying into. And a further thing that we can build on top of this, as you can see here, we've got separation of parameters, is the separation of the resources themselves. So in development, I've got a DynamoDB table, but it needs to be named differently than the table in production and in staging so that they don't overlap. So as I'm deploying, I need to have a strategy for parameterizing these resource names as well. Once we parameterize those, now we can start to build up other components of our application, whether they're scripts or maybe front-end JavaScript code that runs inside of a browser. These environments or these code pieces that need to access different environments, we can now tell them, you're running in production, so you need to hit noisyherd.com, or you're running inside of dev and staging, and so go look at these other environment-specific locations for where the API endpoints are.
Another challenge is that with serverless, the definition of local development has changed. So having a local version of your application all on your machine is no longer possible. And we mentioned environment isolation before. Well, that applies to each developer as well. Because serverless uses managed cloud services, each developer needs their own isolated environment, their own playground, if you will, for their own infrastructure to test their code live. And all of this means that local development presents a unique challenge and has several approaches. The first approach is mocking, which means programmatically recreating expected responses from various managed services. So for example, you may have a JSON file that simulates the API events you would be expecting in a live application. And while this is a quick way to develop your code, it's a flawed approach because not only is the data not accurate, you may be missing crucial parts such as the correct roles and permissions for your resources, which wouldn't be discovered until you actually deploy your code out, and then your function is not able to access your database, for example. So another option is deploying after every change and testing your code only out in the cloud. And while this does preserve data integrity, it slows down the iteration process because every deploy takes, say, 2-3 minutes on average. And now a couple minutes isn't really that much, but all of that waiting adds up when especially when you're trying to iterate. It breaks your focus because you're on a roll trying to iterate on your code, and then, oh, gotta wait 2 minutes, might as well get a coffee. Oh, it's been 10 minutes, what was I doing? So yeah, so we thought a hybrid approach was the best way. And this is something we call cloud local development. And in this approach, each developer runs a local version of their function code against the deployed resources in their own dev environment. This is why earlier I showed that each of the Noisy Herd developers has their own isolated environment. So this way, they can access actual data without mocking and know that their function has the correct permissions for accessing the resources it needs to. And they can also see each iteration nearly instantaneously because the actual function code is still running on their machine. They're just making the changes and still accessing resources in the cloud. So what does this actually look like in practice? Well, we have our Noisy Herd engineer, and they've been tasked with writing new functionality that allows users to log in and comment on a live stream. So they just got this assignment, and the first thing they're going to do is check out the latest version of their code base from Git. And this includes both function code and their infrastructure as code template as it is right now live in production. And before they write a single line of Python, they're actually going to break out the infrastructure as code template and add the infrastructure they need to it. So we're talking about a way for users to log in. We need some sort of authentication, say Cognito or Auth0 or something. And then we might need an SQS queue for queuing the messages as they're commands, something like that. So they'll need to add that to their template. Then they're going to deploy that template out to their own isolated dev environment, their own playground. And then they fire up their IDE and they make the changes locally against those live resources they just deployed out. And they keep going on this process, might take a few days, few weeks, whatever, but it's the infrastructure's out in the cloud and they can iterate to their heart's content until the work is done. And when they're done with this new feature, they'll PR both the code and the infrastructure changes, and both will be reviewed as part of the PR process.
So now that we've developed changes, we've got a few more steps before this is ready to be merged into our main source code base. The first is testing, and I always want to make a point of talking about this because it's a point of confusion for a lot of people, especially as they onboard into a serverless architecture practice. Testing for serverless applications doesn't really change in terms of how you do it. You still have unit tests, you still have system tests and end-to-end tests. But the key for system and end-to-end tests, integration tests, is that you have to be able to spin up your entire architecture so that you can hit an API endpoint that then is backed by a Lambda function to write a record to a DynamoDB table, and then test, did the right record get into that DynamoDB table? You have to have a mechanism as part of your testing system to be able to spin up an environment and test just these pieces. This is where CICD really comes in. You want this to be an automated process. So you want, as part of continuous integration, that when a pull request is made, it will automatically spin up a sandboxed environment of your application with the changes that you've made to it. Then be able to run tests that interact with individual components and verify how those components interacted with other components in the system. Ideally, this is all automated so that when you open a GitHub pull request, all of this spin up of an environment, running of tests, and then tear down of the environment happens automatically for you so that you can focus just on the code you're changing and maybe the tests that you're changing along with it. When you have this level of automation for CI/CD, you now have what you need to feel confident every time you're going to deploy your application. This gives you the security to feel like you can do deploys even if it's late on a Friday afternoon. This is the key to the full realization of CI/CD as realized through serverless infrastructure as code approaches. Lastly, I want to step into one area that's been growing as people have gotten more and more proficient with building serverless applications. In larger, maybe more enterprise shops, there's a need to integrate with security practices as well. A lot of people are now calling this DevSecOps. It's processes and mechanisms for how you ensure security practices as part of the development and delivery pipeline. The key is to build this into your processes in a couple of different key areas. The first is make sure you've got environment isolation. You've got some mechanism through infrastructure as code to isolate development from staging, from production, all the way through to permissions. When you're doing this, you need to have a change management process that's demonstrated. This is where having pull requests and CI/CD automated tests comes in handy. You need to have tooling to ensure that as you propose changes, these changes can affect multiple different code bases for different functions in the same application. How will you build up the tooling in an automated way so that starting from the infrastructure as code template, you can find each function, you can descend into its area of source code, and based on its runtime, run vulnerability checks against its dependencies. For example, if it's a node function, you would run npm audit. For a Python function, you'd run Python safety checks, which are going to audit your dependencies for any known vulnerabilities. Lastly, you want to have a way to scan the permissions that you're granting each of your resources. These permissions need to be properly scoped for least privilege access. So for example, if a function needs to access objects inside of an S3 bucket, that function really only needs read or read-write permissions to objects inside of one bucket in an AWS account. But so often, if you look at examples online, they show permissions that look like S3:*, which means this function can now do anything within the S3 service in the AWS accounts, including deleting entire buckets or making contents public when they shouldn't be. Lastly, who can actually deploy these changes into the different environments? This is a mix of how you manage credentials and IAM principles, and you need to have some mechanism and some tooling in place to enable you to safely isolate who has permissions to do these deployments.
So we've told you the what, the why, and a bit of the how of how infrastructure as code works together with CICD in a serverless environment. But none of this matters if it doesn't make your engineering team more effective and your users more satisfied as a result. So how does this combination of everything we've talked about today benefit engineering teams like yours? Well, with a robust local development story, it means no more mocking, no more waiting to deploy, just a quick and accurate way to write function code locally while harnessing the full power of your cloud provider.
Devs with the right environments have the ability now to experiment safely as well. They can do this in parallel, independent of other collaborators on the team. That gives them the ability to be much safer as they're developing changes and not worry about risks.
And for developers, automated testing and deployments means less time doing manual tests that can be scripted and more time building features for their customers.
This creates an ability for teams to be much faster at shipping fixes or shipping new features. After all, I get the greatest satisfaction of being a part of a team that is fast and ships high quality software to our customers.
And finally, even though infrastructure as code lets teams move faster and testing and deployment is easier than ever, you're still able to deliver a safe and secure app for your users thanks to built-in infrastructure as code best practices.
So thanks again for joining us in this talk session today. We really love helping people be successful with serverless application architectures. Everything that we've talked about here has been built up over the past few years as we've helped our customers figure out the best practices for building serverless apps. So we do that at Stackery. Stackery is a product that incorporates many of these facets: CICD, infrastructure as code management, environment management, on top of AWS, helping you design, develop, and deliver serverless applications. So if you don't have these practices yet for your team, and you want to look for something that can help you get there quicker, please check out Stackery. There's a free sign up. You can use it for individual projects as much as you want, side projects that you work on the weekends, or maybe just individual projects at work. And we'd love to be able to help you. But at the end of the day, I just thank you again for sharing your time with us. On behalf of myself and Anna, we really appreciate this opportunity that the Python Web Conference gave us. And we hope that you now have confidence and a sense of the best ways to go build serverless applications.